Hello friends, welcome to video lecture on kinematics of machinery. In the today's session, we'll continue with the problems on instantaneous center rotation method. So here is the problem. The mechanism of a wrapping machine as shown in this figure has the following dimensions. O1A equals to 100 mm, AC equals to 700 mm, the next one BC equals to 200 mm, O3C equals to 200 mm, O2E equals to 400 mm, O2D equals to 200 mm, and BD equals to 150 mm. The crank O1A rotates at a uniform speed of 100 radian per second. Find the velocity of the point E of the bell crank lever by instantaneous center method. So in this way, the problem in front of you. The mechanism of a wrapping machine as shown in figure has the following dimensions. O1A equals to 100 mm, then AC equals to 700 mm, then BC equals to 200 mm, O3C equals to 200 mm, then O2E equals to 400 mm, O2D equals to 200 mm, and BD equals to 150 mm. The crank O1A rotates at a uniform speed of 100 radian per second. Find the velocity of the point E of the bell crank lever by instantaneous center method. So in this way mechanism is given. So what's about the given data? So here the angular velocity of the crank O1A is given. So here we can write omega O1A equals to 100 radian per second. So what's about the length for this O1A? O1A with us 100 mm. Just convert that into meter by multiplying 10 raised to minus 3. So 0.1 meter we can get it here. So we know the linear velocity of the crank O1A. So what's about that linear velocity? So this is the relation between the linear velocity and angular velocity. V equals to R omega. This is the basic formula. So what's about the linear velocity at point A? Or we can just write V O1A equals to VA, because this point is the fixed one. That's why the only we can write VA. So VA equals to angular velocity of this link multiplied by its radius of rotation. Okay. So here we can write omega O1A multiplied by O1A in this way. So what's about this one? 100 multiplied by 0.1 means 10 meter per second. In this way, I can get the linear velocity at point O, at point this one A. So what's about the, now just follow the steps. So what's about the first step? In the first step, you can get the information regarding the number of instance center. Okay. So number of instance centers can be calculated with the help of this relation. Capital N equals to small n into n minus 1 divided by 2. So here in this case, it is very important to redraw that diagram with some suitable scale. Okay, I'll use this diagram for the answer diagram. Okay, so in this case, if we just say here is the crank given. So beside this crank, what's about this one? This is nothing but the fixed link. Give the number 1 for this one. So for the crank, give the number 2 for this one. If we just see this link, entire link AC, give the number 3 for this one, number 4 in the sequence should be given for this one, number 5 for this one, and number 6 for this entire bell crank lever. Our ultimate aim is to find out the the velocity of the point E of the bell crank lever by ICR method. So for that, just say give the number, proper number for this one. One number given should be given for the fixed link. So here is the first link. So here is also a fixed link. So give the same number for this one also. So here is the fixed link. Give the same number. Okay, for this link also. Now, what's about the number given for this one? Number 2 is given here. Number 3 is given for this one. Number 4, number 5, and number 6 is here. Okay. Now, once we get the information regarding this one, small n with a 6, substitute here and do the calculation, you can get the total number of instance center, that is 15. Okay, so once we get the information regarding the number, so get the clear name for that instance center by keeping its record. Okay, So in this way, just prepare the table. So table consists of this indicate the name of the links and this indicate the number of instance centers. So with respect to 1, just write here the instance centers. So I12. So initially give the suffix for that I as 1 and see the number next to this one, the 2 with us. So I12, then number 3 will comes after that 2. So I13, I14, I15, I16. Okay. So last number with a 6. Okay. So that's why I16 will come here. So similarly, in case of the link number 2, this can be written in this way. I number 2 is here. That's why they give suffix for this one as 2. And next to this 2, 3 number with us. So 2, 3. Next to this 3, 4 number with us. So I24. Next to this 4, 5 number with us. So right here I25. Similar case with the I26. Now similarly just write the instance center with respect to link number 3 and other remaining links. Okay. Now if you just count all the instance center, so here we can get the 15 instance center. Okay, count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so once we can get the information regarding this instance center, now move towards the next step. So what's about this step? Locate the fixed and permanent instance center by inspection. Okay, for that do the inspection of this or do the observation of this diagram. So here already this diagram is drawn with some scale. Okay, so in this diagram I'll just if you just see how to draw that diagram. Okay, so here if you just see the question diagram in front of you, see question diagram in front of you. Okay, so already the dimensions for every link in front of you. So O1A is the smaller one, and if you just see here the 700 distance, 700 mm distance with us. Okay, for that I'll just take the suitable scale for this one. I'll just take a suitable scale here. 100 mm equals to 10 mm. Okay, this is the scale. You should write here, but because of that instance center will occurs, that's why I'm just writing the scale on the top side of this diagram. So if you just see here diagram is here in this way. I'll just select the some suitable scale for this one. 100 mm equals to 10 mm. Okay, so with respect to that, just try to draw the diagram. Okay, first of all take this point, after that this distance with us O1A equals to 100 mm. Okay, so as per dimension given, just draw one horizontal line that makes an angle 60 degree, and then we can get this point. Okay, so with respect to this point, what's about the length for the AC given? AC with us 700 mm. Okay, so with respect to this one, just mark here with the help of compass. Okay, and then draw this line parallel to this line. Okay, at a distance of 200 mm, means at a distance of 20 mm. Okay, so draw this line. Now with respect to this point, the distance with us 300 mm. Okay, so with respect to this point, again the distance between this point and this one given 400 mm, means as per our scale 40 mm. So we can get this point, this point. Okay, so what's about the location of this point? Already this 8 point with us, take this distance in compass. So 700 mm with us. Okay, for that just take 70 mm. Okay, in compass, just mark it here. You can again here already this point with us. Okay, so mark this point. The intersection occurs at this spot. This point is nothing but the C point. Now the distance between this one B and C, distance BC is given 200 mm. Okay, so mark here at a distance of 20 mm. Okay, and then mark here one point. Okay, here one point. This distance O2D is also given 200 mm. So mark here. Cross section intersection of both these things will occur at this spot. This point is nothing but the D point. Okay, now join this point and draw one perpendicular line to this one. Okay, now the length for this OE with us, how much? O2E with us 400 mm. In this way, first of all you have to redraw this diagram. Okay, and then once the diagram is over, give the proper number for this one. 1, 2, 3 number 3 should be given for this one, then next one 4, 5, and for this one entire link. Okay, sixth number should be given, and whenever we found any fixed link in the given mechanism, for that also give the same number, that is number 1. Now observe this diagram and locate the locate the fixed and permanent distance centers by observation of this diagram. Okay. Now, so here is the number 1 with us, here is the number 2 with us. So link number 1 and 2. So this point must be I12. I'll give the name as I12. I'll just give the names by some different color. So I12 should be given like this one. This indicates the I12. So 2 link, number 2 is connected with this one. So give number I23 for this spot. Okay. The next one, number 3 is connected with the link number 5. So here the name for this link should be given as I35. Okay, 3 is connected with the 4. So name at this spot should be I34. So 4 is connected with the again number 1. So here I14 name should be given. The next one, 5 link is connected with the link number 6. The entire this one bell crank lever indicates the link number 6. So here I56 should be given at this spot. Okay. Then what's about the next one? Number 6 given for this bell crank lever and number 1 is given for this fixed link. Okay. So this should be I16. Now by inspection, whatever the instrument centers we have located, just circle them. Here is the I12 we are located, then I23 we are located, the next one 3, 5, 3, 4 is here, 3, 5 we are located, then 5, 6 we are located, I4 we are located, then say I16 we are located. Just circle them. Okay. Now move towards the next point, that is locate the neither fixed and nor permanent instance centers by Kennedy's theorem. This is done by circle diagram. Now draw one circle. So draw the circle in this way with some suitable radius. Saying some suitable radius. Okay, not exactly the specific radius is required for this one. Okay. So our task is to just draw that circle and locate the points. In this way, mark 6 points. Why? Because of the 6 links with us. Mark 6 points at an equidistance in that circle. Okay, and give the number for the same. I'll give the number 1 here. 1 number, 2, then 3, 4, 5, 6 in this way. So once the number is given, after this observe this observation table. So I12 already are located. Okay, so draw this one or join this I12 by a direct line in this way. This way. After this 2, 3, 2, 3, just join this one 2, 3 by direct line. The next one 3, 4 with us. Join this one by direct line. So next this 3, 4, 4, 5. 4, 5, if you just see no any connection between this link number 4 and link number 5, no any direct connection. Okay, so this point will not come here. Okay, keep this blank as it is. Okay, now next one 5, 6 with us. So join this 5, 6 with a direct line. Then 1, 6 with us. 1, 6 is here. Join this 1, 6 in this way. Then say 1, 4 is also with us. Join this 1, 4 with the help of direct line in this way. Now my target is to locate the neither fixed and nor permanent instance centers. Okay, for that already whatever the points available with us, that point we have just shown on this diagram. Apart from this one more point with us, 3 5. Okay, 3 5. Just join that 3 5 also with the direct line. This way. Okay. Now first point with us here. This is the first point with us, I13. Okay. So with the help of this circle diagram, just get the path for the same. So I13. So what's about this I13? If I join this I13 in this way, so I13 is the intersection of the two sides of this triangle from this side and two sides of this triangle from this side. So this line is responsible to divide this area into two parts. The two parts must be triangle. So I13 is the intersection of I12, I12, 2, 3, and from this side I14, I14, I34 in this way. Now just find out this point on this diagram. So here I12, I12. So I12 is here. Next one, 2, 3 point is here. I14, I14, 4 point is here, and 3, 4 point is here. So easily we can get that point with the help of extending this line at the back side. Okay, so I'll extend this one by some construction line in this way and extend this line so that intersection of both the line will occur at this point. Okay, so this point is nothing but the I13. Okay, so once I13 point we get, move towards the next one. So I15 with us, I15, I15. So one point is here, another point is here. Okay, so join this. So in this way, join this. And now, if you focus on this one, I16, 56, 13. Okay, in this way. Now, if I consider this area here, the line is not available. Okay, means one can just take this combination I13, then 3, 5, I16, and this one 5, 6. Okay, so 1, 5 is intersection of I16, 5, 6, I16, 5, 6, I13, and 3, 5 in this way. Now find out this, what are the path available with us. So I15 is nothing but the intersection of this I16, 5, 6, then I13, 3, 5. Okay, so here is that I13, 3, 5, 1, 6, and 1, this one 5, 6. Okay, in this way you can get the guideline or path to draw that I15 point. So just find out this I16, 5, 6. I16 is here, 5, 6 is here. The next one I13 is here. Okay, and 3, 5 is here. Okay, so if I extend this line, if you extend this line at the back side, no any use of that. Okay, if I extend this at the front side, then and then only the intersection of this I13 and 3, 5 with the 5, 6 and 1, 6 will occur. So I'll just join this 3, 5 as well as 1, 3 point, and at the same time just show with some different colors so that that can be easily identified. So this point is nothing but the I15. So once I15 point we get, the next one already that I16 point with us. Now my aim is to get the velocity for this point. Okay, now if you just focus here, so whatever the points available in the first column, if that point we have located on this diagram, then as far as concerned with the whatever the problem asked, that points are sufficient. Okay, so remaining point it is not necessary to locate. Okay, whatever the points, whatever the question given, according to that try to locate the points. Okay, all the points it is not necessary to plot here. Okay, So my aim is to get the velocity at point E. For that, I'll just make some relations here. Now proceed for the further steps. Once this actually point located by us, now move towards the calculation of velocity of the point E on the bell crank lever. So for that, let us consider the linear velocity at point E is nothing but the V. Let us consider. Okay. Similarly, you can consider the velocity at this point B is nothing but the VB. Then similarly, velocity at point D is nothing but the VD. Okay. So it is not necessary to get the velocities at this point C, because this B is connected with this one D, and further this D point is nothing but the end point of this one, this bell crank lever. So let us consider the VB and VD is nothing but the linear velocity at point B and D. Now if you just focus here on link number this one, first one, first is nothing but the fixed one, link number 2 with us here. So already the relation for the linear velocity VA with us. So what's about that VA? VA, this actually information with us, VA equals to angular velocity of this link, so omega O1A multiplied by O1A. So already that calculations with us 10 meter per second, okay, in this way. So what's about the steps here? If I consider this I13 as center, just focus on this table. Already this one located by us, this one located by us. Okay. So whatever the point goes out of this diagram, just consider that as center. Here 13 I considered I13 we are considered as center. Okay, for the rotation, and I15 we are considered the next center of rotation. Okay, so initially just consider this I13 as center of rotation and just write here relation. So already this relation we know VA equals to this relation already with us. Okay, now one more relation you can get for that A point, as this A point lies on this link O1A as well as this link AB. So for this A we can write in this way, VA equals to if you just say A point possesses the two motion. One is nothing but the rotational motion if I consider that point on the link O1A. If I consider the A point lies on this AB possesses the translation motion, okay, or linear motion, means it possesses the two motion. When any point possesses the two motion, you have to take the distance of that point with respect to incident center, okay, or imaginary center. So what's about the distance? AI13. So what's about this one? AI13 multiplied by its angular velocity. So what's about the angular velocity of the same? So here we can get the omega AB. This link we are considered for the analysis. Okay. So A point is common between this one and this one. So AI13, this indicates the distance multiplied by its angular velocity. Now just focus at the last point here, B point. So with respect to this B point, you can write in this way, VB equals to, take the distance of this B with respect to I13. So BI13 multiplied by angular velocity of the same link, that is omega AB. So if you look towards this relation we have developed here, I'll just make few changes here in this way. VA, just focus on the equation number 1 and equation number 2. Write this in this way, VA divided by I13A equals to VB divided by I13B in this way, equals to no doubt omega AB. So in this case, VA already with us. Before this, already we are doing the calculations here, 10 meter per second. Okay. So what's about I13A? I13A is nothing but the distance. Just measure that distance with the help of a scale here. Okay. If you just look towards this one, you can get approach here the 0.91 meter by just converting that into actual scale. You can get in this way. So VB divided by I13B. So I13B is nothing but the distance. The distance with us 0.82. Okay. So this distance written here after conversion. Okay. So here VA we know, so get the value for the VB. VB equals to 10 divided by 0.91 multiplied by 0.82. So after calculation, now see here we can get the VB equals to, so already VA with us 10 meter per second. So we know this one, this actually length is measured from the diagram. So 0.91 91 with us, okay, multiply by this 1.82 with us. After calculation you can get the 9.01 meter per second. So here in this stage we can get the VB. So once we get the VB, now this actually written, this relation we are developed by using I13 as center. Okay, so if I consider this I15 as center, then say how we can just develop that relation. Okay, so we just move towards the next point. We can just, by considering that I15 as center, we can develop the relation. Now continue with the next center. Just consider this I15 as center. Here in the sequence I15 with us. Okay, I1 this one. First one I13 we have considered. After that I15 with us. Okay. So what's about this I15? If I consider this I15 as center, we can just write this in this way. Initially we have considered this B point lies on this one AB link. Now consider this B point lies on the BD link. Okay. So from this we can write this relation in this way. BB equals to, just here BB equals to I15 B multiplied by angular velocity of this one is nothing but the BD. So in this we can write the relation. Okay. So similarly, if I just consider this one D point, for that D point, this way we can write that relation I15 D. I15 D point is here, I15 is here. So I15 D multiplied by angular velocity of the link BD. So if you just see here I15, this one I15 D with us. So this relation we have written VB divided by I15 B equals to VD divided by I15 D. So from this one already the value for the VB with us, and measure this I15 B and I15 D with the help of this diagram. Just measure this I15 B. So I15 and B is here. Just measure this one, okay, and convert this into exact scale. Okay, so this value with us 0.13. Okay, so multiply by, so what's about the next one, I15D. So I15D, just measure this distance, so as per this one 0.5 with us, okay, 0.05 with us. Then just substitute here, do the calculation, get the value for VD. So once we get the value for the VD, let us consider the next one, I16 as next center. Here is the I16 with us. Okay, so now not necessary to worry about this I14, because all the connections of this one with us, okay, this one I15, then I13, if you just see this link is connected with the 5, 6 and only this one link number 3. So don't worry about this link number 4 and whatever the instance center comes across that. Okay, so that's why the instead of considering this I14 in between, this one I15 is considered. After that I16 is considered. Why? Because the I16 is here point. That point is available here. So by considering that I16 as center, we can write this in this way. So just consider this D point lies on this one link number 6. Okay, so for that I can just write here BD equals to I16 D multiplied by angular velocity of this link. The angular velocity of this link will remain throughout the same. So D point is here DO2E. DO2E, the angular velocity for this one. Okay, and what's about the next one? If I consider the last point E, then I16 with respect to this I16 we need the distance. So I16E multiplied by angular velocity of DO2E. So if you just see this angular velocity and this one remains same, so we can just write that relation VD equals to I16D equals to VE divided by I16E in this way. Now my target is to get the value for this one VE. So what's about this VD? Already calculations for the VD with us. So VD here 3.46 with us. Just substitute the value for this VD as 3.46. So what's about the I16D? I16D, for that just measure this distance I16D. Okay, already a distance given in the problem. I16D, this value is directly given in the problem. So O2D, that distance is nothing but the O2D. O2D with us 200 mm. Okay, so this indicate the point 2. Multiply by, what's about the next one? I16E. So E point is here, I16 is here. The length for this one is given 400 mm. 400 mm distance given in the in the problem. So this should be taken here as 0.4. Do the calculation, at last we can get the linear velocity at point E is nothing but the 6.92 meter per second. I hope this problem cleared you. Thank you.